Hello, everybody, and welcome to your channel Thermal Engineering Concept and Principle. This is Professor Ali Tarrad. In this episode and series of different videos, we will talk about an application in the field of thermal engineering, which is the most important application in our heat transfer topic. What are the structural components of shell and tube bundle, heat exchangers, and how do they work? In this series, we will talk about this type of heat exchangers and how can we predict the thermal design of such heat exchangers. Welcome again, dear friends and fellows. In this episode, we will introduce more critical information about the thermal design of heat exchangers, specifically the shell and the tube heat exchanger. In previous episodes, we described the construction of the heat exchanger, the type of flow patterns in heat exchanger, specifically the counter and parallel flows of fluids on the tube and shell sides. And we passed through some practical cases where we designed the heat exchanger just to find the surface area without detailed description of the other requirements. And in this episode, we will introduce some other uh, information and requirements before we decide to commence the design of heat exchangers. Usually, there are some selected specifications to be considered before the initiative of the heat exchanger design. Thank you for your support and continuous encouragement to continue our project. Let us go to the objectives of the present video. The objectives of our episode subject for this video can be uh, summarized as tube layout types in heat exchangers and how can these tubes arranged and heat exchanger construction specifications related to other physical parameters of the heat exchanger such as the length, the shell diameter, baffle cut, baffle spacing, and many other parameters. And finally, we will arrive to the summary of the content of the present episode. The tube bank in general has two main tube arrangement in the bundle: the triangular one and the square. And the triangular is usually at an angle of 30 degrees, and it could be rotated to have the shape on the figure top right side, and usually it is rotated to have an angle of 60 degrees. These two types are preferred in tube bundle where we can have higher heat transfer coefficient when compared to other arrangement, and we may accommodate about 15% more tubes in the same size of the shell, and this arrangement is preferable where a clean surface, that is, the fouling effect or the scale is very low, or we can use a chemical cleaning. At the bottom, we have a square where it is arranged in 90 degree or rotated to have an angle of 45 degrees. And this type is usually has low shell side heat transfer coefficient, and of course that will accompanied by a lower pressure drop on the shell side, and mechanical or chemical cleaning can be used. These four arrangements can be used in condensation or in the design of condensers of the type shell side, or even in the um, what is called a surface condenser, such that used in power plants. Some of the heat exchanger construction specifications will be given in this part of the episode. First, we have to decide the tube layout and the tube pitch that to be considered for the tubes, and there are two main or principal types: the triangular 30 degree and the square one 90 degree, as shown in this uh, illustration. And the pitch represents the distance between the centers of the tube that is constructing the triangle or the square, and it is usually either 1.25 times d naught or 1.33 d naught, and this selection depend on the art of design and the requirements, and usually depends on the fluid that is passed on the shell side. Select the number of tube passes. These heat exchangers, the shell and type heat, the shell and tube type heat exchangers usually can be constructed as a single tube pass, as we have described in our previous episodes, or two tube passes, or maybe four passes, and it could be more than that, six or eight. And the selection of the tube passes is also critical and depends on the operating conditions of both the fluids on the tube and shell side. We have to go to pass and calculate the um, bundle diameter, because that will give the shell diameter. And the general form of equation to be used depends mainly on the number of tubes, number of passes, and the shape of the tube layout. The constants K1 and N1 can be obtained from this table, uh, show, uh, which is showing the um, the values of K1 and N1 depending on the number of tube passes and the shape of tube layout. And this table specifically is applied for the pitch, tube pitch, to be 1.25 D naught only. To get the shell diameter, which represents the inner uh, diameter of the shell, that is D bundle, which is calculated from equation number one, plus clearance value that can be obtained from this graph, where it depends on the shape or the mechanical design on the shell side. For example, fixed tube sheet or U tubes, um, out side packing, or whatever. These are only four, and we may get the clearance value depending on the D bundle and the intersection with any of these four curves. Then we have to select the tube length, and the tube length is given by a general form that depend on the ratio between the tube length and the shell diameter to be within the range 5 to 10. These are a general um, parameter or general conditions that can be used in the process of heat exchanger design for the type of shell and tube heat exchangers. Then we have to select the baffle spacing and baffle cut as well. If we consider this shell and the tube heat exchanger, and this is the shell side where we can see the baffle distribution inside the shell. We have baffle cut, which could be a percent, and baffle spacing. And let us consider single tube of a bundle just to show the process. And we have a flow, the flow on the tube side and flow of fluid on the shell side, as shown in this illustration, and heat transfer can be exchanged between these fluids. The uh, buffalo spacing is usually range between zero point 0.2 to 1.0 times the inner shell diameter, and this range is given by TIMA standard. And we have also the baffle cut to be in the range between 15 to 45% of the inner shell diameter. And of course, the selection of the percent of this uh, baffle cut depends also on the condition of the fluid and its properties that is passing on the shell side. General form could be 25% uh, of the inner shell diameter can be used. These are the most important parameters to be considered when designing heat exchangers from the type of shell and the tube. As a summary of the present video contents, uh, we describe the main two types of tube layout arrangements in heat exchanger. They are the triangular and square tube arrangement with a pitch range between 1.25 or 1.33 times d naught, the diameter, the outside diameter of the tube, and then the heat exchanger construction specifications to be considered before before the initiation process of the design of heat exchanger, because these factors affect the final shape of the heat exchanger. And we have to keep in mind that the heat exchanger design is a sort of art, and uh, as we go deeply in this um, topic, we may find that when a final stage could be the thermal design of heat exchanger, which could be the optimum design that could be selected. We have some useful references you may pass to get them, because I seated them in a PDF with a link in the description box below this video. And thank you for listening. And please subscribe and share this video with your colleagues. And I will see you uh, soon in a new episode about this series, which is related to thermal design of heat exchangers. Bye bye.